Hey everybody! In today's lesson, we're going to be covering the whiteboarding technical interview. A technical interview evaluates your ability to do the job of a professional developer. In a whiteboarding technical interview, you'll be asked to stand in front of a whiteboard and write out code to solve a problem. For this lesson, we're going to cover common strategies that will make sure you're as successful as possible in this interview. This lesson will cover clarifying the problem that's being asked of you, coming up with inputs to give to your function and what outputs you can expect, outlining the strategy of how you'll approach this problem with the interviewer, writing the actual code of the problem on the board, testing out the code that you've written with your inputs, and finally analyzing the time and space complexity of the code that you've written. For each of these lessons, you'll follow along with a piece of paper and a pen at home, and then watch the video to see how we did it. Let's get started. So for our first step, we're going to clarify the problem. Now, when the interview begins, you'll be standing in front of the whiteboard and the interviewer will give you a problem that they'd like you to solve. The first thing you want to do is repeat that back to them and then clarify any ambiguities. So for example, if an interviewer were to say, I'd like you to write a function that returns the duplicate characters in a string, I may say back, all right, I'm going to write a function that takes in a string as input and I'm going to return a count of the characters in the string. So how would you like that count returned? Would you like a dictionary that has a key of the letter pointing to a number indicating the amount that that letter occurs? Would you like maybe a Boolean that returns if there are duplicate characters at all? You know, what is it that you're looking for? And in this way, I'm starting a dialogue with the interviewer, and I'm also getting a concrete idea of what exactly do they want me to write on this board. Some other questions that may come to my mind are, do I consider spaces duplicate characters in a string? Do I consider different cases duplicate characters in a string? So is a lowercase a and a capital A, are those duplicates? Stuff like that. For our lesson, we're going to focus on one problem, and that problem is going to be, given a list of numbers, return whether a Pythagorean triplet exists in that list. Okay, so one of the first questions you may have is, what's a Pythagorean triplet? And that's totally fine. If that's something that you're not clear about, you're not being tested on your knowledge of Pythagorean triplets, so you can ask the interviewer, I'm not quite sure of that term, can you explain it to me? And they may say something like, well, in the Pythagorean theorem, if we have a right triangle here, and we have the sides A, B, and C, the Pythagorean theorem states that a squared plus b squared will equal c squared. So if we plug numbers into these values, say we have a 3 here, a 4 here, and a 5 here, this should be true. So if we have 3 squared plus 4 squared, that's going to equal 5 squared. We'll do some quick math to check that out. We've got a 9 here, we've got a 16 here, and we have 25 here. And sure enough, that works. So now we have a more concrete idea of the problem that we're going to be solving. So to recap, the reason why we want to clarify the problem is to make sure that there are no disagreements or miscommunications between yourself, the interviewee, and the interviewer. And that way you can focus on solving the problem. Once we've clarified the problem, we'll move on to coming up with inputs and edge cases for our problem. Now, this is an extension of clarifying the problem, but it really makes it very concrete, this solution that you're trying to find. So what we're going to do here is imagine some inputs to this function that we've yet to write and write out what the expected output would be. So again, our problem of looking for Pythagorean triplets in a list, I'm going to want to have a list of integers. And this is, again, a communication or a dialogue that I'm having with the interviewer to make sure that we're on the same page. Now, the very standard example I would go for is what I'd call the happy path, or a very straightforward representation of what I would expect this function to return true for. So again, I have my three sides, 3, 4, and 5, and I would expect this input to return true. Again, this is something I would check with the interviewer to make sure that this is what they expect. This is pretty standard. Now I'd start to think to myself, what are some inputs that this function could receive that may cause a problem with the way that I'm thinking about solving this problem? And what I mean by that is, we're doing this Pythagorean triplet problem. And if I have, for example, an input of -3, 4, and 5, I know that a triangle can't have -3 as a side. But if I square -3, it's still going to return true if I'm just doing a squared plus b squared equals c. To make sure that we're on the same floor. So there are some inputs. What I mean by that, I know that a triangle can't have -3 as a side. But if I square -3, it's still going to return true if I'm just doing a squared plus b squared equals c squared. Now this could be an issue, and I would talk to the interviewer and say, should I expect to receive negative numbers in my input? And the interviewer may say, you don't have to account for that, or that's a good thing to account for. You'll need to provide for that in your solution. Something else that I may want to include is maybe just, what if I get a list of only 4 in it? Something less than the 3 numbers that I'm looking for. Will I account for that in my solution? Something else that I may want to think about is the sort of flip side to this. This is my very simple true solution. Maybe I would pick another input that's like 12, 1, and 3. So this would be my returning false case. By providing these inputs and talking them through with the interviewer, I'm continuing to shape the problem and clearly define what is expected of me before I turn to writing code. Code is very specific and unforgiving. Given an input, it gives you an output. So I'm using these inputs to really narrow down what I'm expected to write. And I think that this has given me a good variety. Ultimately, to walk through the problem, I might just stick with my happy path and then maybe an edge case of having less than 3 numbers in the input or a negative number. So just to recap, the reason why we use inputs is to lead us towards a very clear definition of what our function should do, as well as revealing some edge cases of tricky situations we may not have considered to begin with.
This is OutSystems.
With a clarified problem and explicit inputs and outputs, we're ready to start outlining our solution. Now this step is going to vary the most because it's highly dependent on the problem that you're given, but there are a few takeaways that are going to apply regardless. The number one thing to remember is these interviews are about communication and thought process. You want to make sure that this is a dialogue with your interviewer. Even if you're really, really stuck and you can't think of any way moving forward, talk to your interviewer. Tell them why you're stuck. Tell them the parts that are hanging you up, and they may offer you a hint or a suggestion to get you unstuck. Now, for this specific problem, we're looking for 3 numbers in our input list that satisfy the equation of a squared plus b squared equals c squared. So what we're looking for is a way to pull 3 different elements out of the list, do some math, and a comparison. Now, to be able to pull 3 elements from a list, what I can do is use loops. Specifically, what I can do is, starting a loop here, maybe at 12, I can nest another loop, and for that first iteration of 12, I can look at 1, 7, and 9. That would give me 2 elements. But I'm looking for 3, so I'll have to nest another loop inside. So for my first iteration of 12, my second iteration would start at 1, and then the third iteration would look at 7 and 9. So again, I would have my A and my B, and then my C's would be 7 and 9. This loop would conclude and move over. Then I would have 1 and 7 as my A and B, and look at 9. And that's sort of my approach for pulling out those three elements. This is something that I could discuss with the interviewer. They may poke some holes in it. They may say, well, have you considered this aspect or that aspect? But that's what I'm going to go with in this step. Once you have an agreed solution with the interviewer, before you turn to the whiteboard and start writing out your code, step over to the corner where you have your inputs and outline your solution to keep yourself on track. So for my solution, my first step is going to be to iterate. I'm going to iterate through the list. Then I want to nest another iteration that starts one element over. And because I'm pulling three elements out of my list, I'll have another nested iteration, one element over. This is something that I could one element over. I have another nested iteration, one elements. I'm going to square them and compare them. That'll be my last step. So to recap, we're going to outline the solution. In the beginning will be a dialogue with our interviewer. Here's how I'm thinking about approaching the problem. Here are the obstacles or the challenges I'm facing. Maybe the interviewer is going to offer me some hints or some input that I'll incorporate into my solution. And then when I've agreed upon an approach with the interviewer, I'll step over and make some quick notes to keep myself on track when I'm writing out the actual code. Okay, we've got an outline of our solution. We've got some explicit inputs and outputs. There's nothing left to do but to write some code. Now for this step, you may be tempted to just turn to the whiteboard and code out your solution in silence. But we want to remember this is still a communicative process, right? We want to give our interviewer, who could be a potential future coworker, an idea of how we work. We want to communicate with them the whole time when we're writing code. So we're going to follow these steps. We're going to use our outline to communicate that next step that we're going to write, and then we can write that up on the board. And during that time, maybe we won't be talking, but overall we'll continue to refer back to the steps and why we're writing that specific portion of code. So the first thing I have to do is define my function signature, and I want to iterate through the list. And my function takes in a list as in. Now for this step, you may be tempted to just turn to the whiteboard and code out your solution in silence. Who could be a potential future coworker, an idea of how we work. We want to communicate with them, outline to communicate that next step that we're going to write, and then we can write that up on the board. And during that time, maybe we won't be talking, but overall we'll continue to refer back to the steps and why we're writing that specific portion of code. So the first thing I have to do is define my function signature, and I want to iterate through the list. And my function takes in a list as input. Great. And now I want to iterate through my list. And specifically, I'm iterating by grabbing an index variable. And now I want to nest another iteration because I'm looking for the next element over. And now because I don't want to include duplicate elements, I need to start this iteration from 1 over the previous variable. So I'll do I plus 1, and then the length of the list. And I need to iterate one last time to get that third element, so I'll nest another iteration. And again, I want to iterate 1 over from the previous variable, so that's j plus 1 in this case. Great. I have my 3 loops. That means I can pull out my 3 elements. The last step is to square and compare, so I will pull those elements out in a comparison. If the element at index I squared plus the element at index j squared is equivalent to the element at k squared, then I've got my Pythagorean triplet, and I want to return true. Now, if I iterate through all of these loops and I never return true, that means I never found 3 elements that form the Pythagorean triplet, and I want to return false. Great, and now I have my coded solution. Along the way, I used my steps to communicate what I was doing at each step of the way. Whenever I need to make a decision on the code, I would explain that, and there we have it. With a written solution on the board, you may be tempted to pull a mic drop and say, "I'm done." But don't do that, because chances are you've written something incorrect on the board. Or even if you haven't, you want to show your interviewer that you're someone who cares about the code that you write. You don't take it for granted that it runs perfectly. You've tested it. So what we're going to do is pull one of our explicit inputs, plug it into our function, and talk through the execution of the code. This is another opportunity to show that you understand the logic of what you've written and you can communicate it to a coworker. So we're going to plug in 3, 4, and 5 to be our list. We're going to loop for I in range of the list. Here's a mistake. So what we're going to do is pull one of 3, 4, and 5 execution of the code. This is another opportunity to show that you understand the logic of what you've written and you can communicate it to a coworker. So we're going to plug in 3, 4, and 5 to be our list. We're going to loop for I in range of the list. Here's a mistake. I left off an E. I can add that in. So we'll say I is equal to 0. We're going to go into our second loop, j in range I plus 1. So j is going to start off as 1. And we'll go into our third loop, k in range j plus 1. K is going to be 2. And we're going to check if the value located at I is at index 0, the value would be 3. So that value squared would be 9. Plus the value located at j squared. We have the first index, which corresponds to the value 4. That squared would be 16. Is that equivalent to the value located at k? K is the second index. Second index is 5. That squared would be 25. So I can see here that that does return true. I made another syntax mistake here. I can add in a colon, and I'm going to return true. So for this instance, my function does what is expected. I can test it out again. Maybe I have my input that should return false, that just has one element. So in this case, I is in the range. I is going to be 0. J is going to be I plus 1. And we can see that there are no more elements. So I'm actually never going to be entering into any of these loops. This iteration will pass. I is going to be incremented. We'll break out of that loop, and I'll return false. So it works for this case as well. Now, the reason why I want to do this by stepping through the code is I caught a few mistakes. These were syntax mistakes. But at this point, the interviewer may say to me, well, have you considered a different type of input? And this gives me an opportunity to defend the code I've written or make an adjustment and correct a bug. So in this case, I've actually made a mistake. My function assumes that the values will be in ascending order. I'm always comparing earlier values to a later value. What this means is if I got the input of 5, 4, and 3, this should still return true. But my function, the way it's written, won't return true. I'm assuming that the values are in ascending order. So given a mistake like this, or a bug, it's important not to panic, because mistakes happen all the time in programming. What I need to do is take a step back and think, well, how can I adjust my function in order to still return a correct input with this new input? So what I can do here is sort my list. If my function assumes that the values are always going to be in ascending order, I can just do that in my function. And I'll sneak it in here. I'll just put a little arrow. We'll do list.sort. And now I know that my values will always be in ascending order, and my function should work as expected. So again, to recap, when we've written out our solution, we always want to test it explicitly. We want to take the inputs that we put on the board, plug them into the function, and talk through how the function is executed. If along the way we come across any mistakes, don't panic, correct them in time, or discuss with the interviewer where you want to stray and how you can fix it.
JavaScript, Python, type.
All right, at this point, we've talked through our solution. We know that it works. We're feeling really good, but we're not quite done. There's one final step that the interviewer may ask for explicitly, but even if they don't, you'll want to supply this information. And that's the time and space complexity of your code. Developers care about the efficiency of their code, and time and space complexity, or big O notation, are a way of communicating how fast your code will run in relation to the input. May ask for explicitly, but even if they don't, you'll want to supply this information. And that's the time and space complexity of your code. Developers care about the efficiency of their code, and time and space complexity, or big O notation, are a way of communicating how fast your code will run in relation to the input. In other words, if I give a larger and larger list as an input to this function, am I doing a lot more work, a little more work, no more work? So to analyze this code, we have one iteration for the length of the list. We have another iteration. So this iteration for the length of the list is going to happen for each element. So this would be n, or n is the length of the list. For n, we have n iterations, so that would be n squared. And then we have yet another iteration for n cubed. N cubed is maybe not the best time complexity, so I might talk to the interviewer about ways that I can optimize my code or increase the efficiency. If I'm going to increase the efficiency of this code, I need to do less work than n cubed. Now, it may occur to you how to find an optimal solution, or it may not. It's worth talking through it with the interviewer, but you may not always be able to come across the optimal solution. It's possible, again, that the interviewer will give you some hints or suggestions that can guide you down that path. For this problem, there is a way that I can make it run a little bit more efficiently. Now, I'm going to talk through how I would do this, because the first step is sort of a proof of concept with the interviewer. So what I'm showing is, let's say I have an input that is these numbers. So there is a Pythagorean triplet in here, right? The first thing I'll do is square the numbers. And what I can do is look at the very last element in the array. And I can iterate backwards from the largest to the smallest. And within that iteration, I can set up pointers at the next value over and the very first value. And these can be my AB and my a squared plus b squared equals c squared. So I'll add these together of 1 plus 16, and that gives me 17. Now 17 is less than what I'm looking for, my c squared of 25. So I can increase this by moving this pointer over to 4. That's going to give me 4 plus 16, which would be 20. I'm still not at 25, and I'm still less than 25, so I'll move this pointer over again. And now I have 9 plus 16, which would be equal to 25. Now this is the happy case where I found the solution, but each of these iterations of finding the value in the middle by moving these two pointers, this is only going to be one iteration. So I have one iteration moving from the back, and then within that iteration, I'm moving pointers. That would be an n squared time complexity, which is an improvement upon the n cubed that I have here. Now at this point, the interviewer may try to punch holes in my approach. They may say, that sounds great. You don't need to write out that code. They may say, that sounds great. I'd like to see you code that solution. I should be prepared for any of those eventualities. The most important part is, again, I'm continuing my communication. I understand the efficiency of code is important, and I know how to break down my code. Okay, everyone, we're done with our problem and our lesson. So let's recap the steps of how we got here. We were asked a question by the interviewer. Now, our first step was to make sure we understood the question that was being asked of us. We tried to solidify any ambiguities and make sure we really understood what the interviewer was asking. Once we had a firm idea of the problem, we came up with some practice inputs to test out exactly what our function should return. When we had these inputs, then we discussed our approach to the problem. How are we going to solve it? This was a dialogue with the interviewer, and we ended up with some high-level steps that guided us to a solution. Once we had these high-level steps, we used them as a signpost to be able to code out our actual coding solution. And when we had the code on the board, then we took those inputs, we plugged them into the code we had written, and we stepped through the execution at every line to make sure it worked. We caught some mistakes along the way, and we made some adjustments. When we were sure that the code we had written solved the problem as asked, then we thought about the efficiency and the time complexity of our code, and we brainstormed an idea to make it a more efficient solution. All along the way, we made sure to check in with the interviewer and talk about our ideas all along the way. We want to make sure that we have a good impression with this future coworker, and they remember that we're a thoughtful, communicative person. Thanks for watching.